apologize. So again, that should be 63 degrees. So let's just redo that real quick. 12 times pi times 63 equals divided by 360. Okay, that's going to give us 6.6 instead. So this is about 6.6 centimeters. Yeah, centimeters. Those are always tough ones. So hopefully that helps. Okay. I'm basically just deciding how many degrees did it travel instead of how many miles an hour I traveled, right? If I go 30 to 65, that's 35 miles per hour, right? That it changed. So how many degrees is that? So I just needed to change 35 miles an hour into degrees, which is 63 degrees. Okay, let's move on. 44. So these are all kind of similar questions, just like the last one, just put in different terms here. Let's read this. The minute hand on the clock is pointing to 10. How many degrees will it travel if it moves clockwise from 10 to 5? Okay, so how many degrees will it travel if it moves from 10 all the way around to 5? Well, hopefully you're thinking that what's a full circle in terms of the degrees? A full circle is 360 degrees, right? Do you see how this clock is sectioned off into 12 equal sections of 5 minutes, right? 1, 2, 3, 4, 5, all the way to 12, right? Those are all 12 equal sections. So if I take 360 degrees and divide it by 12 equal sections, that'll tell me what each section is in terms of degrees. Why don't you guys divide that? What's 360 divided by 12? Punch it into the chat what your answer is. It's 360 divided by 12. Type it into the chat. Good. Nice, very good, very good. 30 degrees, right? So why is that important? Well, that tells me that every 5 minutes is 30 degrees then, right? Every time the hand goes 5 minutes, it's traveling 30 degrees, right? That's all we're doing. So if it goes from the 10 all the way to the 5, how many of those did it travel, right? Well, I can just add all these up, or basically that's just multiplication, right? How many 30 degrees did it go? Why don't you guys type that in? How many degrees did it travel if it goes from 10 to 5? Let's see what you guys got. Not quite. Look at it carefully again. See, look, 30, 60, 90, 120, 150. I got to go 2 more times, right? 180, and then 1 more time is, there you go, 210. Yep, 210 is correct. So how many degrees will it travel? 210 degrees. How many degrees will it travel if it moves clockwise from 10 to 7? Okay, well, aren't I just adding another 30 degrees on, right? I just go 2 more times, right? So what's that going to be if I go another 2 times? If it goes from 10 to 7 instead of 10 to 5, I'm just adding 60 degrees on, right? So that's going to be 270 degrees, right? And if I kept going, it would be what? Then 300, right? 300 degrees, 330 degrees, and then finally 1 more time all the way back to the start would be 360 degrees. All right, let's go to these questions here. If the minute hand on the clock above is 11 inches long, how far will the end of the hand travel when it moves from the 10 to the 5? So it's how far does the hand travel? It's not degrees. I think what they're looking for is distance. So that's a circumference question. So we know that the circumference of a full circle is pi times diameter. They don't want the full circle. They only want from 11 to 5. Well, we know, we just answered that what? From 11 to 5 is 210 degrees of the circle, right? So that's arc length. So we're going to multiply this by the angle 210 out of 360. That's all we're going to do. Okay, so it says the minute hand of the clock is 11. So that would be the radius of the circle. So the diameter is just times 2. 11 times 2 is 22. So I'm going to say 22 pi times 210 divided by 360. And then from here, you just let the calculator do the work. Let's punch that in. 22 times pi times 210 and then divide that by 360, and we get 40.3 approximately. And it is, where are the units at? Inches, there they are, inches. So we're going to say 40.3 inches approximately. If you guys have questions, you can send me a private message too, or a public message. Just speak up. If the minute hand on the clock above is 33 centimeters long, so now they're changing the minute hand, it's now 33 centimeters long. How far will the hand travel when it moves 25 minutes? Okay, well, we need to know how many degrees 25 minutes is, right? Well, we know that every 5 minutes is 30 degrees, like we previously talked about, right? So every time the hand moves 5 minutes, it goes 30 degrees, right? So 25 minutes, that means it's basically 30 times 5, right? If I go 25 minutes, okay, it's just going here. Maybe it'll make sense if it's kind of hard to show you guys through video, but let me do my best. Let me erase this. Okay, so we know that every 5 minutes is 30 degrees, right? So let's say I'm starting here at the 12 and I go 5 minutes. Well, that's 30 degrees, right? If I go another 5 minutes, it's another 30 degrees. Another 5, 30, that's 15 minutes, right? Another 5, 20 minutes. Another 5 is 25 minutes. So how many degrees is that? Do you see how it's 30 times 5, right? That's where I'm getting that from. 30 times 5 is 150 degrees, right? So how far will the hand travel? Again, that's circumference. So circumference equals pi times diameter. That'll give me the distance around the entire circle. I do not want the entire circle. I only want 150 degrees of the circle. So I just multiply this. This is arc length, 150 out of 360. Again, the diameter, so that it said that the minute hand was 33 centimeters long. So 33 is the radius times 2 is the diameter. So 66 is the diameter. So 66 pi times 150 out of 360. Now we just let the calculator do the work. 66 times pi times 150 and then divided by 360. And I got 86.4. So we're going to say approximately 86.4 centimeters. All right, let's keep it moving. I've covered 45 and 46, you guys. I covered questions just like those in last week's videos. So if you need help with like those ones, go back and look at last week's videos. I did questions just like those when we did sector area. So the 45 is a sector area question, and 46 looks like a, it's 46 is sector area again too. So go back and look at those sector area videos. All right, but for the sake of time, I gotta try to squeeze as much in as possible here. So let's finish up with these last three here. Just a couple more minutes. At the local pizza palace, you have a choice of the following 2 slices of pizza. So it looks like we got 2 slices of pizza here, slice A and slice B. You can see slice B looks like it looks like, I don't know if it's larger. It looks shorter, but covers a wider area maybe. I don't know. They're different prices. Like they have different degree measures as well, right? And different radiuses. So it says calculate the area of each slice. Then compare the cost per square inch and determine which slice is the better value. So slice A is $1.90, slice B is $1.75. I almost want to say like, who cares? It's only 15 cents, but it's cool. It's cool to be able to like use math and answer these types of questions though. Write your final decision in complete sentences. So I'll kind of guide you through this one and then you guys can write your final decision in complete sentences. So we just need to find the area of each slice, right? And then compare it to its cost. All right, so area of the circle, right? Because if I had a full pizza, it's a circle, right? So I'm going to say area is pi times radius squared if I wanted the full circle. I don't want the full circle for slice A. I only want, what's the angle? 48 degrees, right? So I'm going to multiply this by 48 out of 360. And the radius is 10, right? So 10 squared times pi. So 10 squared is 100, right? So 100, I'm plugging in 10 for the radius there. 100 pi times 48 divided by 360. All right, let's punch that in. So 100 times pi times 48 divided by 360. So the area of that slice is like 41.9 square inches. So what I'm going to do that, I want to find the cost per square inch, right? So I need to take my square inches, 41.9, and I'm going to divide that by the cost, right? Do that now in your calculator. So you're going to take 41.9. That's the area of that slice of pizza, right? And we're going to divide it by the cost of it, which is $1.90. 41.9 divided by 1.90. And I'm getting, sorry, my calculator, I had to clear it out. So again, 1.9. So I'm taking the cost and I'm dividing it. 1.9 divided by 41.9. Okay, I'm getting like 0.045, right? Which is 5 cents. So I'm getting 0.05, which is 5 cents, right? Per square inch. That's how much it costs, 5 cents per square inch. Let's do the same thing for slice B. Slice P, pi r squared, but I want to multiply by 62 out of 360, right? I don't want the area of the whole circle, just that portion. Again, the radius for this one is 8. So when I plug in 8 squared is 64. So 64 pi times 62 out of 360. 64 times pi times 62, and then divided by 360, and I get 34.6. That's the area of that slice. So you might think, oh, you know, so which is the bigger slice? Slice A is bigger, right? Because I compare their areas, right? Slice A is a bigger slice of pizza, right, than slice B, but that doesn't mean it's a better buy, because remember, slice B is actually cheaper. So it doesn't mean, you know, we have to figure out what the better buy is, not what the bigger piece is. Just because it's bigger doesn't make it the better, you know, in terms of cost. So again, I'm going to take the cost of slice B, which is $1.75. So $1.75, and I'm going to divide it by its area, which is 34.6 inches squared, right? So $1.75 divided by 34.6 gives me 5 cents. Look at that. So what's the better buy? What do they both cost? They look exactly the same. They cost the exact same. One's more expensive, but it's bigger, right? So the question is, what's the better buy, right? So in this case, neither of them are technically the better buy. They technically cost the same. All right, let's move on. 49. What's the circumference of this gear? Okay, I'll let you guys do this one. I'm just going to go over it real quick because of time. Circumference of a circle is pi times diameter. That's all you got to do. Okay. Now we got a little bit of time. We can do this one pretty quick. So it says if the circumference of the gear is 42. So where am I going to plug 42 in for? It's telling me that's the circumference, right? So 42 goes in for the circumference, and then I'm solving for the radius. Well, I'm just going to plug 42 in for the circumference. 42 equals pi d. And then look, I can solve for d by just dividing both sides by pi. So 42 divided by pi will give me the diameter. So if I do 42 divided by pi, I get like 13.369, right? But it doesn't want the diameter, it wants the radius. Well, all I need to do then is just divide that by 2, right? The diameter divided by 2 equals the radius. So if I just divide that by 2, I get about, the radius is approximately 6.7 centimeters. Last one, we'll finish here. And then I'll let you guys ask questions if you have any. It could be here or just about anything. If the area of this cracker is 11 pi, what's the radius? Okay, so area of a circle is pi times radius squared. It says the area is 11 pi, so I plug that in for area. 11 pi equals pi times radius squared. Question is, what's the radius? So I'm just going to solve for the radius. I'm going to divide by pi on both sides, so you can see that pi cancels on both sides. So now I have 11 equals r squared, and then I just square root both sides. And that'll cancel that. So the radius is the square root of 11. And then we can approximate that. We usually do that. Square root of 11 is about 3.3 centimeters. And that's it.